Hey everyone, I will be introducing to you the chapter on sequences and series, a topic that is found in the H2 Math Pure Side syllabus. Alright, so I'll just be going through some key definitions and key terms in this video and also introduce some new notation that you may not have seen before. So firstly, let's define what a sequence is. So a sequence is basically like your number patterns, right? So number patterns is basically an example of what a sequence is. But more generally, sequence is basically an arranged order of numbers. Alright, so these numbers are basically arranged. It could be anyhow, right? It could be like, let's say, need not follow a pattern. Could be such as 1, 2, 6, and whatsoever. And whatever it is, right, is an arranged order. So it's arranged very specifically in that way. More technically, it's an arranged order of numbers, also known as terms or elements. Alright, so it could be something like, let's say we have an example of sequence is odd numbers, right? Positive odd numbers 1, 3, 5, 7, and 9. So you see there are 5 terms here. I mean, that's possibly more. I don't have the time to write a lot more. So this is basically an arranged order of numbers. Obviously here there's a specific pattern, but we may not have a pattern. So for example, we can have something like 2 and then 5 and then, like, let's say suddenly -6 and 8 comes out and then -100. It's also possible, right? It need not follow a specific pattern. You just need to have a sequence of number and a range order of numbers. Whatever it is, it contains terms or elements. So we're able to assign the nth term, or we're able to find the nth term. So let's say the first number is 1. Let's say you look at these two examples. The first term is either 1 or 2. Alright. So this could be the first term. This could be a second term, and so on and so forth. However, we are also able to express this nth term more mathematically with u subscript n. And the good thing about this is that we need not assign the first term as being actually the first term. We could assign the first number as, let's say, the 0th term. So we have u0, then the next one being as u1, the next one being as u2, and so on and so forth. We can also stick to very classically the first number being the first term as u1, the second being u2, the third being u3, and so on and so forth. Alright, it doesn't matter. However, once you pick one, so let's say you pick the first number as the 0th term, the next number must be the first term. Alright, so do be consistent. Don't jump like, let's say, the first number being the 0th term, then the second number being the second term. It doesn't work that way. Alright, when you stick to one, be consistent. So we talked about sequence already. Let's look at what does it mean to have a series. Alright, so a series is basically the sum of first n terms. Alright, again, we could represent it as Sn. Alright, you can use another letter like D subscript n or Z subscript n, up to you, but more universally S subscript n. So the sum of n terms, so basically we have u, let's say the first term, let's say I'm using the second one here, so u1 plus u2 plus u3 plus all the way to u subscript n minus 1 plus u subscript n. So this is basically the series. Alright, series is basically sum of the first n terms in a sequence. Okay. Now in this chapter as well, you get to learn what we call by the sigma notation. So the sigma notation is represented as this. Alright, it looks like an E. Alright, basically it means summation. Alright, so summation, let's say from summation of values from x equals to, let's say, 0, or actually let's put it more generally, x equals to a to x equals to b. So for example, actually no, so as you can see from here, how do you use a sigma notation? Basically it works like an integral sign, right? There's a lower limit, so let's say x equals to a, the upper limit is just simply b. Alright, then inside is basically the formula or the function you want to apply the sigma notation to. So you can have like fx or u subscript x. Okay, so it's really depends, alright? So basically what it means is that, let's say I have the sigma notation of x equals to a to b fx. It's basically the sum of fa plus fa plus 1 plus all the way to fb. Alright, then if I have, let's say, the summation of x equals to a to b for u subscript x, then it will be basically the ath term plus the a plus 1th term plus all the way to the bth term. Alright, so basically this is the ideal sigma notation, and as you can see, right, it also ties into your series. Alright, so from here you can also write the series of n terms, so the summation of n terms as the summation of, let's say, accounting with this, right, my first term is 1, so n equals to 1 to 20 un. Alright, so there we have it, the introduction of sequences and series.